So let's go ahead and look at an example of how to do a proof by contrapositive. So I've written up here the basic idea of how to do a proof by contrapositive. And what we're going to do is apply it to actually one of the examples that we've seen previously. So we had a proposition, and that proposition said, given A, B, and C real numbers, and A is greater than B, if AC is less than or equal to BC, then C is less than or equal to 0. And we've already seen how to do this using a direct proof, and it was a little bit tedious. So let's see if we can do this using a proof by contrapositive and show how it's a little bit more straightforward. So typically, the way that you start these proofs out is you declare that you're going to argue contrapositively. So arguing contrapositively, we will show, and then you take your proposition, you take the P implies Q statement, P implies Q right here, and you write down what the contrapositive of that is. So what we will show is the following. So I took this statement right here, if P then Q, and I took its contrapositive. I took not Q, so I flipped my inequality right here, implies, and then I flipped my inequality right here. Instead of greater than or equal to, or less than or equal to, it's a greater than sign right here. So now I have this statement right here, and I know that's logically equivalent to what I had beforehand. That's what that says. So we assume that C is greater than 0, right? So we're assuming not Q. So this right here, this was our P, that's our Q. We are assuming not Q. Not Q, that's this guy right here. So we're going to assume C is greater than or equal to 0. Now I'm going to take advantage of the fact that I was given that A is greater than B. Well, if A is greater than B and C is a positive number, I can just multiply C all the way through this inequality right here, and none of my inequalities flip. We get AC is greater than BC. And hey, that's exactly what we were trying to show, right? And so we are finished. And so you can see the power of arguing contrapositively, because instead of considering your original statement P implies Q, sometimes it's a whole lot easier to consider the contrapositive statement, not Q implies not P, and then your proof could be rather straightforward right here.